in occupied France. August 1943, just after 4 in the morning, on a quiet Luftwaffe airfield, Oberleutnant Werner Schulz, Chief Technical Officer of Jagdgeschwader 26, received news that seemed like a triumph. An American P-47, Thunderbolt, had been forced to land. Its pilot was captured, and the aircraft itself was nearly undamaged. For the German High Command, this was an intelligence treasure. For months. Luftwaffe pilots had reported strange encounters with this massive American fighter, its strength, speed, and endurance seemed beyond reason. Now, for the first time, German engineers could examine one up close. When Schulz first saw the P-47 on the tarmac, his reaction mirrored that of every German pilot who had faced it in the sky. It looked absurdly bulky, almost comical, like an oversized milk bottle trying to fly. But because he was an engineer, not a combat flyer, his curiosity overpowered his judgment. He believed in numbers, not appearances. What he was about to discover would reveal a grim truth: the P-47 was not grotesque. It was a glimpse into the future. A machine that mathematically proved Germany was already losing a war its leaders still thought they could win. Before the war, Schulz had worked at Messerschmitt as an aeronautical engineer. His job now was to analyze captured aircraft, find weaknesses, and recommend countermeasures. Standing beside the captured P-47, he took in its massive fuselage. It was built around a colossal radial engine and weighed nearly 8 tons when fully armed and fueled. In contrast, Germany's own Focke-Wulf FW-190 weighed about 4 tons. Pilots jokingly called the P-47 the Fliegende Flasch, the flying milk bottle. Looking at its broad, rounded shape, Schulz could see why. It looked too heavy to fly, too large to maneuver. But numbers, not appearances, would decide the truth. He began his inspection carefully, and what he found left him deeply unsettled. The heart of the machine was the Pratt & Whitney R2800 double wasp engine. When Schulz's team removed the cowling, silence fell over the hangar. Before them stood an engineering marvel: 18 cylinders arranged in 2 perfect rows of 9, forming a powerful radial configuration. The P-47's bulky shape now made sense. It was built to hold this giant engine and its complex systems. But the size alone was not what shocked Schulz. It was the precision, the craftsmanship, and the sheer industrial capability behind it. Every cylinder was perfectly machined. The crankshaft gleamed, balanced with flawless symmetry. The metal alloys used were beyond what German factories could easily replicate under wartime strain. Schulz took out his notebook, began to calculate, and quickly realized the implications. The double wasp's displacement and turbo-supercharged design meant it could produce at least 2,000 horsepower, possibly more. In comparison, Germany's BMW 801 engine, which powered the FW-190, produced around 1,700 horsepower at its maximum limit. That engine represented the peak of German technology. Yet the Americans were producing engines with 20 to 30% more power on an industrial scale. Because of this, Schulz understood that Germany was not just fighting pilots in the air. It was fighting factories, engineers, and entire industries capable of achieving what his nation could no longer match. But it got worse, much worse. Schulz began inspecting the P-47's engine construction for signs of wartime compromise, the sort of shortcuts German factories had been forced to adopt because of material shortages and Allied bombings. He looked for evidence of low-grade metals, simplified castings, or rushed assembly methods. He found none. Every surface gleamed with precision. The Pratt & Whitney R2800 had been built using high-quality aluminum alloys and fine bearings that showed no sign of wear or substitution. This engine had been built the right way, not the desperate way. One of Schultz's assistants, a veteran mechanic who had worked on countless German aircraft, leaned closer and pointed to the cylinder bank. "Herr Oberleutnant, look at this," he said quietly. "Each cylinder can be removed by itself. If one fails, they can replace it without taking apart the whole engine." Schultz studied the layout and nodded slowly. It was brilliant. The Americans had designed for practicality, not just performance. This approach meant faster repairs, fewer grounded planes, and more aircraft returning to combat within hours rather than days. In comparison, German engines demanded extensive disassembly for even moderate repairs. The American design accepted that engines would need maintenance and built for it. Because of this, the Thunderbolt could keep flying while others sat grounded. But as Schultz continued his inspection, something else drew his attention, something that made his stomach tighten with unease. The true secret behind the P-47's astonishing power was not only its engine, it was the turbo supercharger system. He had read reports about it before, but seeing it firsthand was different. The system was a masterpiece of wartime engineering. A complex maze of metal ducts ran from the engine through the fuselage to a turbine mounted at the tail. The exhaust gases from the engine drove this turbine, which in turn powered a compressor spinning at more than 20,000 revolutions per minute. This compressor forced pressurized air back into the engine, allowing it to maintain full power even at extreme altitudes. The precision required was extraordinary. Those ducts had to withstand temperatures that would melt ordinary metals. The bearings inside the turbine had to survive speeds that would destroy weaker materials. Every measurement, every angle, every bolt had to be exact. Because if any part of the system failed, the engine would tear itself apart. German engineers had experimented with turbo superchargers too, but the challenges had always been too great. The alloys required to handle the heat were scarce, and their factories simply could not produce the necessary precision at scale. They had abandoned the idea, yet here stood an American fighter, one of hundreds already flying, built with that very technology. Schultz made quick notes and calculations. The numbers were stunning. With its turbo supercharger, the P-47 could maintain full engine power far above 25,000 feet. At those heights, the thin air sapped the strength of German fighters like the Bf-109 and Fw-190. Their mechanical superchargers could no longer supply enough oxygen, and their engines struggled for breath. But the P-47 with its advanced system was only getting stronger the higher it climbed. It could meet the American bombers head-on and still outclimb or outdive its German opponents. Therefore, in the realm where Germany needed control most, the high altitudes over Europe, the Americans now held the advantage. His assistant broke the silence. "Can we build one, Herr Oberleutnant?" he asked. Schultz looked at the maze of pipes, the turbine, and the polished metal that seemed almost otherworldly. He didn't answer immediately. He knew the truth. Because to build something like this, Germany would need not only better materials and machines, but also time, and that was something they no longer had. Schultz shook his head. "Not with our current manufacturing capacity," he said quietly. "This system demands precision machining, high-grade steel alloys, and thousands of hours of skilled labor. We are already struggling to produce enough basic aircraft. Because of that, adding this level of complexity," he paused, "is beyond our capabilities." The realization was crushing. The Americans had not only built a superior fighter, they had built a machine that reflected an entire nation's industrial strength. The P-47 was more than a weapon. It was proof of what an economy free from shortages could achieve. Germany, by contrast, was fighting a war it could no longer afford to sustain at a technological level like this. After completing his inspection of the engine, Schultz turned to the airframe. What he saw deepened his concern. The captured P-47 had taken heavy damage before landing. Cannon shells had torn through parts of the fuselage, and machine gun rounds had left holes across both wings. Yet the aircraft had not fallen apart. It had stayed in the air long enough for its pilot to land safely. Schultz examined the torn metal carefully. There were clear marks from multiple 20mm hits, the kind of damage that would have instantly destroyed a German fighter. But this machine had endured it. Its thick aluminum skin, strong internal structure, and duplicate control systems had all kept it alive. He reached for combat reports from Luftwaffe units and saw a repeating pattern. German pilots had fired full bursts of cannon fire into P-47s, expecting them to fall, but they watched in disbelief as the American aircraft kept flying. The reason now stood in front of him. The P-47 was built like a flying fortress. Where German designs focused on lightness and speed, the American engineers had chosen resilience. Every part of the Thunderbolt was made to survive. The cockpit was heavily armored, with steel plates guarding the pilot from every angle. The front windscreen was made from thick, reinforced glass. Even the massive R-2800 engine acted as armor. Because it was an air-cooled radial, it had no fragile coolant lines or radiators like the German liquid-cooled engines. You could damage part of the P-47's engine, even destroy several cylinders, and it would still run. Schultz reviewed Allied field reports confirming that many P-47s had returned to base with multiple cylinders destroyed, fuel tanks leaking, and control surfaces damaged, yet they still landed safely. A Bf-109 or FW-190 with that kind of damage would never have made it home. One of his engineers studied the aircraft's structure and muttered, "It's over-engineered." They added weight for strength that could have been used for performance. Schultz agreed, but explained quietly. "Yes, but they can afford it. They have engines powerful enough to carry that weight. We don't. We have to cut every kilogram because our engines cannot overcome it." That was the heart of it, a difference not just in design, but in philosophy. Germany built machines that pushed their limits, refined to the edge of what was possible. The United States built machines with margins of safety, redundancy, and power to spare. Because of that, the American approach was proving more effective. Germany had brilliance, but America had scale, industry, and reliability. Schultz realized that this difference, more than any single battle, would decide the outcome of the air war. Schultz examined the P-47's armament next. 8 Browning M2, 50 caliber machine guns, 4 mounted in each wing, stared back at him like silent predators. His expression darkened as he began to calculate what this meant in practical combat. Each gun carried around 400 rounds, for a total of 3,200. Together, they could unleash more than 100 bullets every second. The destructive power was staggering. A single 1-second burst could send 100 heavy, high-velocity rounds tearing through the sky. A typical 2-second burst would double that, hurling 200 rounds toward an enemy aircraft. German fighters, by comparison, were far more lightly armed. A Messerschmitt Bf-109 usually carried 1 or 2 cannons and 2 machine guns. Ammunition was limited, perhaps 60 rounds for the cannon and about 500 for the guns. Once those were gone, the pilot had no choice but to turn back. The P-47 pilot, by contrast, could fight across several engagements before exhausting his ammunition. Because of this, American pilots could stay longer in battle, sustain multiple attacks, and dominate the skies through sheer persistence. But it was not only about quantity. Schultz studied the 50 caliber rounds themselves and realized their terrifying efficiency. Each was a heavy, armor-piercing slug designed to punch through metal and bone alike. Reports from German pilots had described their encounters with P-47s as flying into a wall of lead. Now Schultz understood why. 8 guns firing together created a single, focused cone of destruction. Anything that entered that cone would be torn apart in seconds. German aircraft, designed for agility and lightness, could not withstand that level of concentrated fire. Precision was almost unnecessary. The P-47 pilot only had to bring his target roughly into view and squeeze the trigger. Schultz made a note in his report, recommendation: avoid head-on combat with P-47. Probability of survival: minimal. As Schultz compiled his technical report, he began to notice a deeper pattern, one that transcended engineering or tactics. Every part of the P-47 reflected an industrial foundation of immense power. The engine required precision machining and rare alloys. The turbo supercharger demanded advanced metallurgy and flawless manufacturing. The airframe consumed vast quantities of aluminum. The 8 Browning guns required an enormous ammunition industry to support them. Each of these systems would have been a major achievement for any nation to produce individually. The United States had combined them all into a single fighter and was building thousands. To confirm the scale, Schultz requested updated intelligence on American aircraft production. The figures that came back were almost unbelievable. Republic Aviation was manufacturing over 500 P-47s every month by late 1943. Plans were already underway to expand production to 600, 700, perhaps even 800 per month by 1944. Germany, by contrast, was struggling to produce between 300 and 400 single-engine fighters monthly across all models combined. And because Allied bombers were constantly targeting factories, those numbers fluctuated wildly. Schultz stared at the data in silence. The numbers told a story more powerful than any weapon. The Americans were not just building airplanes, they were building an air war on a scale Germany could no longer match. But the numbers got worse. The R-2800 engine was not unique to the P-47. It powered several major American aircraft. The total wartime production of this engine alone would exceed 125,000 units, each producing 2,000 horsepower. In contrast, Germany's entire output of aircraft engines for all models throughout the war would be around 250,000, and most of them were far less powerful. The Americans were building more of a single high-performance engine type than Germany could produce of all its engines combined. The imbalance was staggering. Schultz sat at his desk, surrounded by notes, blueprints, and reports. He ran his calculations again, unwilling to accept what he was seeing. But every figure told the same story. American aircraft production for 1943 was projected to surpass 85,000 planes. Germany would manage about 25,000. On paper, that was a 3-to-1 ratio, but in practice, the gap was even wider. American aircraft were heavier, larger, and more complex, demanding far more material and labor per unit. A single B-17 Flying Fortress required as much aluminum and manpower as 3 Bf-109 fighters. Yet the United States was producing thousands of them. Because of this, the disparity went beyond numbers. It was industrial reality on a global scale. America was not only supplying its own forces, but also sending thousands of aircraft and tanks to the Soviet Union under Lend-Lease. It was arming the British, equipping Allied nations, and still outproducing Germany in every category. The industrial map of the war revealed the truth: Germany was fighting nations that had become factories of war, while its own factories were being bombed nightly. When Schultz began drafting his final report for the High Command in Berlin, he understood the danger of what he was writing. His findings laid out, in clear engineering terms, why the P-47 Thunderbolt represented a level of technology Germany could not match. He detailed its superior engine, its unmatched durability, and its overwhelming firepower. But beyond the technical data, the report contained a conclusion that could easily be viewed as defeatist. His summary read, "The P-47 Thunderbolt represents a level of industrial and technological sophistication that exceeds Germany's current capabilities. Its widespread presence in the air demonstrates that American production capacity far surpasses previous intelligence estimates." Recommendation: tactical adjustment to avoid direct engagement with the P-47 at high altitude. Strategic assessment: continued attrition against a numerically and technically superior enemy will lead to unsustainable losses. In plain words, it meant only one thing: Germany could not win this battle in the air. Continuing the same tactics would only lead to destruction. When Schultz presented the report, his commanding officer read it in silence. After several long moments, he looked up with a mixture of respect and unease. "You realize," he said, "this will not be well received in Berlin. They do not want to hear that American aircraft are superior." Schultz met his eyes and asked quietly, "Should I change the findings?" The officer shook his head. "No, the report is accurate. But be prepared. The leadership does not react kindly to uncomfortable truths." Schultz nodded. He had known that before he began writing. Because for the first time in the war, the numbers had spoken louder than ideology. The report was sent up the chain of command. Schultz never received an official reply, but word reached him through informal channels. His findings had been dismissed as overly pessimistic. One staff officer reportedly remarked, "This engineer has been demoralized by enemy propaganda. The P-47 is just crude American engineering, inferior to our designs." Schultz was not surprised. He had seen this pattern before. Any intelligence that clashed with Nazi ideology or challenged the belief in German superiority was ignored, no matter how accurate it was. Yet for Schultz, the examination of the P-47 had changed everything. It had not only revealed the power of a single aircraft, but had exposed a truth about the war itself. Germany was no longer fighting as an equal. In the months that followed, his predictions began to unfold with painful precision. More and more P-47s appeared over Europe. German fighter losses rose sharply. Experienced pilots were lost faster than they could be replaced. The tactical recommendations Schultz had outlined, avoiding high-altitude combat and relying on quick hit-and-run strikes, were slowly implemented. But by that point, the strategic balance had already shifted. The Americans had seized control of the skies through a combination of numbers, endurance, and technology. Schultz continued his work, examining other captured American aircraft, and each one reinforced the same conclusion. The materials were better, the systems more advanced, and the production methods clearly industrial in scale. He once inspected a captured C-47 transport plane. It was solid, reliable, and built for efficiency. The Americans had produced over 10,000 of them. Germany's entire transport fleet, by comparison, consisted of only a few hundred aircraft, many of them outdated. Then came the P-51 Mustang. Sleek, agile, and deadly. It combined the range of the P-47 with even greater performance. Its engine was a Packard-built version of the British Rolls-Royce Merlin, manufactured in the United States under license. Thousands of these engines rolled off production lines that seemed to have no limits. Every aircraft Schultz studied told the same story. Germany was losing not because of poor design or lack of bravery, but because it was being overwhelmed by a nation whose factories could outproduce entire continents. What troubled Schultz most was not ignorance, but denial. The intelligence existed. German agents in the United States had already reported on American industrial strength. Captured aircraft proved the quality firsthand. Yet leadership chose not to believe the numbers. Or worse, they believed them, but insisted that willpower and superior tactics could overcome material inferiority. Schultz had been trained as an engineer. He trusted numbers, calculations, and physical laws. And the numbers told a story no belief could erase. Germany was being buried beneath an avalanche of American steel. After the war, when Allied production data became public, Schultz's estimates were proven conservative. He had actually underestimated American capacity. Between 1940 and 1945, the United States produced over 300,000 aircraft. Germany, during the same period, produced about 94,000. The United States alone built more than 15,600 P-47 Thunderbolts, more than the total number of Bf-109s and Fw-190s Germany managed to produce combined during the late war years. As for the R-2800 engine that had left Schultz in awe back in 1943, over 125,000 were eventually built. Not only by Pratt and Whitney, but also by Ford, Chevrolet, and other American automobile companies that had transformed their peacetime factories into wartime production centers. It was this fusion of engineering excellence and industrial power that had ultimately determined the outcome. Schultz never forgot the day he first stood before that captured Thunderbolt, because in its shining metal and perfect machinery, he had glimpsed the truth about modern war victory no longer belonged solely to the pilot in the cockpit, but to the factory worker, the engineer, and the vast machinery of industry that stood behind them. The industrial mobilization that made these numbers possible was unlike anything the world had ever seen. Across the United States, factories that once produced automobiles were converted to manufacture aircraft engines. Assembly lines that had built sedans now turned out fighter planes. Shipyards that had launched freighters were now launching aircraft carriers. America had transformed into an arsenal of democracy. Because of this transformation, it was not just about producing in large quantities. It was about maintaining quality across the board. Late-war American aircraft showed no signs of decline. There were no shortcuts, no signs of material exhaustion, and no compromise in workmanship. In contrast, German aircraft production was crumbling under pressure. The evidence was everywhere: lower-grade metals, simplified airframes, and weakened quality control. Skilled craftsmen had been drafted into combat, replaced by untrained or forced laborers. As the war dragged on, the difference in output became more than numerical. It was industrial, structural, and moral. Schultz survived the war. When it ended, he was questioned by American technical intelligence officers who had discovered his 1943 report on the P-47 Thunderbolt. One officer asked, "Did you really conclude from examining a single aircraft that Germany would lose the war?" Schultz paused before answering. "I concluded that Germany could not win an industrial war against the United States," he said quietly. The P-47 was proof of that. Every part of it, from the engine to the bolts, represented a production capacity we could not equal. The aircraft was more than a weapon. It was evidence of an industrial empire. The American officer leaned forward. "But you were just one engineer. Surely others saw what you saw." "Many did," Schultz replied. "But in the Reich, telling the truth was dangerous. Admitting that the enemy was stronger could be taken as defeatism. So most remained silent." The officer opened a file on the table. "We found your report in Berlin," he said. It was stamped, "Filed. No action required." "Did that surprise you?" Schultz smiled faintly, but there was no joy in it. "No," he said. "I expected that. The leadership never wanted honest intelligence. They wanted confirmation of what they already believed. When reality contradicted their ideology, they chose to ignore reality." The story of Werner Schultz and the captured P-47 stands as a reflection of Germany's deeper failure. A dedicated engineer examined a single enemy aircraft and reached a conclusion rooted in fact, not ideology. He understood that Germany was losing an industrial war it could not hope to win. Yet his warning went unheard. His experience mirrored that of other German figures who had faced the same wall of denial. Admiral Wilhelm Canaris warned that American industrial strength would determine the outcome of the war. Albert Speer, Germany's armaments minister, privately admitted that no amount of efficiency could overcome the Allies' material superiority. Fighter ace Adolf Galland recognized the P-47's tactical dominance, while General Sepp Dietrich knew the Ardennes offensive would fail because there was simply not enough fuel to sustain it. All of them were men of expertise and experience who saw the truth clearly. But they lived in a system where truth had no power, where ideology stood above reality. Therefore, the story of Schultz is not only about a captured aircraft. It is about the failure of a nation to listen to reason. Germany's engineers, strategists, and soldiers could fight bravely, but against an opponent that could outproduce them 20-1. Bravery was no longer enough. The P-47 Thunderbolt became more than a symbol of American air power. It became proof that in modern warfare, numbers, machines, and industry decide the future long before the first shot is fired. The Nazi regime was built on a belief that German racial and cultural superiority could overcome any disadvantage. Its leaders convinced themselves that determination could replace resources, that ideology could defeat mathematics, and that belief was stronger than industry. But they were wrong. Men like Werner Schultz knew they were wrong the moment they began examining the evidence. Because understanding the truth and having the power to act on it are not the same thing. Schultz's report on the captured P-47 should have been a turning point. It should have forced the German High Command to reconsider the entire foundation of its war strategy. The facts were clear, the conclusions undeniable. Yet the report was quietly filed away, ignored by those who preferred fantasy over arithmetic. Meanwhile, the P-47 Thunderbolt went on to make history. More than 15,600 were produced. They escorted bombers across Europe, tore through German airspace, and destroyed thousands of enemy aircraft. They supported the Allied invasion of France and helped secure the air superiority that made Germany's defeat certain. But behind those numbers lies a deeper truth. It all began with one engineer standing on a quiet airfield, examining one captured airplane, and realizing that his country had already lost a different kind of war. It was not a war of soldiers or strategy, but a war of factories, fuel, and raw materials. It was a war of production, a war fought in foundries, shipyards, and assembly lines. The side with more oil, more steel, more aluminum, and the ability to turn them into machines of war would always prevail. America had all of those things in abundance. Germany did not. Therefore, long before the first Allied soldier landed on the beaches of Normandy, the outcome of the war had already been decided in the echoing halls of American industry.